Hello all. I welcome you all to the last week for the course Principles of Downstream Techniques in Bioprocess. Of course, this live interaction session was held on the 14th of October, but due to some technical glitch, I was unable to have a good audio of the recording. So I'm unfortunately unable to upload the original live session. So this will be a recording, a re-recording of the week's questions that we solved on that day. So hope this helps you prepare for your exams. The topics covered were drying, distillation, and future trends. But the questions were restricted to drying and distillation, of course. So the first question is drying in a hot plate is based on option A conduction, B convection, C radiation, and D sublimation. Since this is not a live session, I'm not going to wait for the participants to respond or think about it. So I'm directly going to jump into the answers so that saves time for both parties. And I believe today is the last day for you all to submit your week 12 assignment. So the answer is conduction because there's a direct contact between the vessel and the hot plate. Right, hot plate is an instrument that has a coil, a heating element, which is in direct contact with the uh, substance to be heated. Okay, so this is contact base and conduction is the process. So this is a picture of a hot plate. Question 2: what will be the surface area in meters square per kg of polymer spray droplets of density 2.3 gram per cc and size of 50 microns? So first of all, what we have here is density is equal to mass by volume, right? And you're having it as 2.3 grams per cubic centimeter, or you can call this way. So I'm just going to change the units. Hmm, Since 1 meter is 100 centimeters, so it will be 100 centimeter the whole cube, which is going to give us 600, right? And 1000 grams is 1 kg, right? So density is 2300. I'm just using the three zeros to move the decimals. Okay, and mass of one droplet is equal to density into volume of one droplet. So what is the volume of one droplet? 4 by 3 pi r cube. And what is r here? 50 by 2 into 10 power minus 6 because it's in micrometers, right? So diameter is equal to 50 into 10 power minus 6 meter. So what would this give us? So first I'm going to do 25 into 10 power minus 6 whole cube into pi into 4 divided by 3 into 2300. So I'm getting this as 1.505, excuse me, so that is 1.505 into 10 power minus 10. So meter cube and meter cube will cancel, kg. This is mass of one drop, right? Now in 1 kg of polymer, number of droplets would be 1 divided by 1.505 into 10 power minus 10. So the number of droplets that you have is equal to 6644518,272. Area of one droplet is equal to 4 pi r square, and area of so many droplets per kg is equal to 6644518,272 into 4 into pi into 25 into 10 power minus 6 whole square in meter square. So the answer would be 25 into 10 power minus 6 square into 4 into pi into 6644518,272. So I've in Google Drive I've uploaded the PPT that I have used for the live session. There might be slight variations because of the decimals that we choose. So in case the PPT, I mean the answer that I am getting here and what we have it there in those slides is different, just as long as it's within the marginal error, just ignore it. This is the answer that I'm getting now, 52.186 meters square. Question 3. With respect to problem 2, if the drop size is decreased by 5 times, what will be the surface area in meters square per kg? So initially my radius is 25 into 10 power minus 6 meter. So the new radius is decreased by 5 times. So it is 5 into 10 power minus 6 meter. So the density is going to be the same. Rho is equal to 2300 kg per meter cube. So we have to mass is equal to rho into V. 2300 kg per meter cube into volume will be 4 by 3 pi 5 into 10 power minus 6 cube. Right, let's do this. So 5 into 10 power minus 6 whole cube into 4 divided by 3 into 5 into 2300. So that is 1.204 into 10 power minus 12 kg. So in 1 kg of polymer, number of droplets would be 1 divided by 1.204 into 10 power minus 12. So this gives me 83 0 sorry 8305 6478 4100 droplets. So area is equal to 4 pi r square into number of droplets equal to 4 into pi into 5 into 10 power minus 6 square into 830564784100. Is that right? So what I'm getting here is 260.93 meters square. Okay. Same process, both questions. Yeah. Question 4. Two ends of a rod 15 centimeter long are at temperature of 30 degrees Celsius and 100 degrees Celsius. The thermal conductivity of the rod K. So this is your K, T1, T2, and the area of cross section is 2 centimeter square. What is the rate of heat transfer? So Q is equal to what? Equal to Ka del T by L, right? So K is 2.5 joules per centimeter degree Celsius into second, multiplied by area is 2 centimeters square. So we cancelling 1 centimeter here into del T 100 minus 30 degrees Celsius divided by 15 centimeter. So this centimeter and this centimeter go away. So this is 2.5 into 2 into 70 divided by 15 joules per second. The units of joules per second. So what is this? 23.33 joules per second. That's a rate of heat transfer. Question 5. Vapor pressure of pure ethanol is 43.7 mmHg at 20 degrees Celsius. What will be the partial vapor pressure offered by ethanol in mmHg in a mixture containing 0.35 mole fraction of ethanol? So partial vapor pressure of ethanol is equal to mole fraction of ethanol into vapor pressure of pure ethanol. So that will be 0.35 into 43.7 mmHg, right? 43.7 into 0.35 will be 15.295. In problem 5, it is a binary mixture. So binary of ethanol plus water. So x water plus x ethanol is equal to 1. Right? This is mole fraction of ethanol, mole fraction of water. So put together it is a whole mixture which is 1. Then what is the partial pressure offered by water in mmHg if vapor pressure of pure water is 17.5 mmHg? P water is equal to uh, xw into pure vapor pressure, and xw is equal to 1 minus xc into, so 1 minus 0.35 into 17.5, which is 0.65 into 17.5, which is 11.375 millimeter mercury. Compounds A and B with boiling points of 80 and 100 degrees Celsius form a high boiling azeotrope. When we are talking about high boiling azeotrope, the boiling point of the azeotrope will be over 80 and 100. So greater than 100 is your right option. Not less than 80, not between 80 and 100, not equal to 80, it's greater than 100. In lyophilization, drying occurs by A. Evaporation, B. Distillation, C. Sublimation, and D. Convection. So in lyophilization, you go below the triple point of water where you move from solid state directly to vapor phase, right? So it is through sublimation, not by distillation or evaporation or convection. Sublimation is the right answer. So with that, we come to the end of this week's question. So one of the participants who attended the live session had a question on how to solve a problem where you had two different points, and heat transfer was given with coefficient of h in joules per centimeter square per second. It was a planar surface, I believe. So this was a convective heat transfer, and it was solved by this equation: q is equal to ha dt. And some other previous week's questions were asked as doubts and we solved. I hope this video is useful to you. Thank you very much. I'll also upload this PPT in case you need it.